Hi student. In the last video we was discussed about direct addressing mode. So just I am briefing that uh, the area in which you want to access the directly, that is a scratch area that is in the RAM, the located by 32.7FH as we know that, and similarly the entire 128 bytes of RAM can be accessed through the SFR or else with the direct addressing. And as we know that in direct addressing we have discussed already, if you are mentioned as a sign indication in the operand, it indicates that it is a immediate addressing mode, so that there is no hash sign in the operands. We given an example also. So these examples in this 40 is the direct addressing. The content is loaded into R0. Here the accumulator content loaded into the area of which the 56H is pointed. So this is what the direct addressing. We'll see continuation of it. We have the SFR register and their addresses, so that we can access the register through their address. Let me have the first one. See, move 0E H 55H. So this is as we know that the immediate value, this is an immediate addressing mode, and this is immediate, and this is your direct addressing, the operand whichever I mentioned. So it is similarly like E0 is an address holds in the RAM area. It is an accumulator address, so that the value I put it directly to the accumulator through the it address. So this is the direct addressing mode. We have some more example. So we have the 25 is moved to the F0. F0 is address of B register. So it means that the 25H is moved to the B register. So similarly we can mention the SFR register address in our operand to access its memory location. So similarly the R2 content is moved to the E0H. So this is your register addressing, and this is your direct addressing, so that I can move the content of register into the direct address pointed by E0. So that is E0 is an accumulator, so it is similar operation perform both the instruction, but addressing the operand is different. This is your register addressing mode, so this is your direct addressing mode. Similarly we have one more example. The R0 is copied into the F0. F0, it is, as we know that it is holds the B register, so that the content of R0 is copied into the B register. So these are the examples. We can check out their SFR, check out their addresses in the RAM area, so that I can mention in the operands. So we'll see that some of SFR addresses as already discussed in the register in the first module. So here we have the some special function registers. So we have a addresses accumulator. It is a bit addressable, so that is E0. B register, it is a bit addressable, and program status word, it is a bit addressable, D0. Like all the registers have their its own address in the RAM area. It is in internal RAM area, so that I can access that address through these values. We'll see some of examples here. So write a code to send 55 to the port 1 and port 2 using their names, first one, and their addresses, so that we should know the port 1 and port 2 addresses in the SFR region. So port 1, it is the address. See, this is the port 1, it is 90H, and port 2 is A0H. We should remember that, so that I can copy the value, that is 55, into the port 1 and port 2. So let me see that the first one, I taken the value into the accumulator. I need to use their names only, so that I can send the value directly to the port 1. So port 1 it is 55H, and similarly port 2 it is 55H. So here instead I can directly write that move P1 comma hash 55H, and similarly move P2 comma hash 55H. This also I can write the instruction to move their values to the port 1. But here the second is to be mentioned to their addresses, so that I require the address of P1 and P2. From the table I can came to know that the P1 address is in 80H and P2 is in A0H, so that I can write the value into the 80H as well as A0H. So move A comma 55, I move the value into the A register, from A register to P1 address holded by the 80H. Similarly, the content of accumulator, that is 55, moved into the P2, that is the address holds by A0H. So this is the programming I can write in different forms to represent the register or represent the address of the special function registers. Similarly, the direct addressing can be mentioned to operate on the stack. As we discussed, the stack operated in the last in first out operation mode, and the stack pointer holds an address, that is top of the stack is 07H. Once the refresh or reset the RAM, so all the content of the RAM becomes 0, but stack pointer holds the top of the stack, that is 07H, as we know that. So in the stack and direct addressing mode, only direct addressing mode is allowed for pushing or popping the stack. So let me see that push A is invalid. I can't, the content of accumulator is not possible to push into the stack area. So I can do that the push E0H, that address E0, it is pointed to the accumulator, so that the content of that A register is pushed onto the stack. Remember, the push A is invalid. You remember that the push, the content, it was only addressing, direct addressing. We can do it is only the direct addressing only. Okay, so this is your direct address to access the A register, so that I can use the push E0H. So some of the, one example I'm taken, show the code to push R5. See, I'll write the stack area. This is my, let me assume that this is stack area, and this is the address is 07H. It is the new top of the stack, that is stack pointer Wilson address. SP is Wilson address, stack pointer is Wilson address. So once you use the push address, push instruction, then top of the stack become incremented by 1, and it is stack pointer holds this address 08H. The value here you're pushing the 05 in the sense the RAM address holds by the 05, it is R5. The content of R5 is pushed onto the stack. So this is the what I written here, push R5, it is over. And similarly push the A content also. A is E0H, so that I push to the A0, then again the stack pointer is incremented by 1, and here the content is A, that is 09H. This is your stack in the RAM area. Okay, so this is also over. The content of R5 and the content of accumulator is pushed onto the stack. Then we need to pop them back. As we know that it will be works in whatever it is, first in last out or last in first out operation. So this is the last in accumulator that should be popped back to the some of the register through the direct addressing. So here what I want to do is pop them into the R2 and B register. So the values of whatever we have, the value of R5 and A, we should pop it back to the R2 and B register, where the B is equal to A, R2 and R5 is equal to the same. So B is equal to A means that accumulator content I need to pop back. This accumulator content I should pop back to the which register? B register, because A is here, it should be B is equal to A I supposed to do. Similarly this I should be into the R5 should be into the R2, because I given that R2 is equal to R5. So such a way that first I should pop it back the A register into B register. So B register address, as we know that it is F0H, so that I use the pop instruction. Similarly I need to R5 content into R2, that address is 02, so that it pop back the value into the R2 register. So this is very much clear about how the stack is working, as well as how we can access the stack through their addresses. So remember, here the push and pop will works with only the direct addressing mode. Let me have the register indirect addressing mode, next one. So in register indirect addressing mode, through the register is used as a pointer to the data. So it is indirect addressing mode, so that it is works as a pointer. See, this is the value. Let's say the data I can access through the indirect means this has a address. Let's say address is 20H. If I want to access this data directly, I can access 20. This is direct. So indirect means first I can mention this 20 into some other register. Let's say RI. I can say that it is RI. So RI holds only the two register, that is two register R0 and R1. So let me have the R0, so that the 20 holds R0, that content is indirectly pointed to this data. So this is how I can mention as a indirect. So in the C programming, as we mentioned as *P. P holds an address of 20. The value star, it is value at that P, it is the data whichever I mentioned here. So this is what indirect addressing mode. So as we discussed, only the register R0 and R1 used for this purpose. So R2 to R7 cannot be used to hold the address of any operand located in the RAM area. When R0 and R1 holds the address of RAM location, they must precede it by add symbol. Remember, if there is an add symbol, indicates that it is in indirect addressing mode. So we have an example. So here move A, R0. R0 holds an address. That content is moved to the, this is moved to the accumulator. Okay. Similarly here the B register content, it is moving into the R1 pointed by that address in the RAM area. So this is what the indirect addressing mode. So let me have the name we called as indirect addressing mode or the register indirect addressing mode. Both are the same. We'll write one simple program to be understand clearly with direct addressing as well as indirect addressing mode, with the loop and without the loop. So write a program to copy the value of 55 into RAM memory location 40H to the 41H. So the program is simple. The value, it is 55, I supposed to write to copy into the location. One is 40 and another one is 41H by using direct addressing mode and register addressing mode. So first we'll do it with the without looping. Let me see that. Here the value 55 I loaded into accumulator. The first one, the value, put it into the 40H. It is very simple. It is direct addressing mode. So I put into the directly to the accumulator content into the 40H, and similarly 41H I put in directly into the accumulator. See this, it is, I directly mention the address as 40 and 41. So this is your direct addressing mode. Next, same thing I want to mention in the indirect addressing mode, so that this 40, it is pointed to the one of the register, that is it should be R0 as well as R1, any one of the register it can be pointed into that. So I'm taken the value into accumulator, so that R0 I added the 40H. This is the address holds the R0 value. The first value I moved into the 40, so that I can move into the 40. Next location I taken into 41H, so that I increment the R0. R0 become now it is 41. So the value, the accumulator content I put in into the 41H directly. So it is very simple. Here it is very two addresses directly I can mention here. If I have the 10 location, so that how I can mention 10 address directly, so that it is a drawback while writing the program in direct addressing mode if this is in the loop. Okay, so indirect addressing mode, it is very efficient working in the loop. Let me see that it is very simple. I'm taken the value into the accumulator. The pointed address is R0. It is pointed to the 40H. So how many values I want to taken the direct values? So I am taken the two addresses 40 and 41, so that I taken the loop value, it is 2. So what I'm going to do is first the value. See, this is very simple code. So accumulator content 55 I move to the R0 pointed by this. This is the value. It is moving into the 40H. So increment the R0. Now R0 become 41H, so that I can check that content of R2 it is 0 or not. So DJNZ is decrement jump not 0 of R2. R2 will decrement by 1 now. R2 now it is 1. So it is not 0. Coming back here, the accumulator content is pushing into the 41H now. So here 55. In the previous loop it is 55. So now increment R0. So R0 will be incremented to next loop it is 42. It is incremented. Now decrement the R1. R1 is decremented to 0. Now so it is jump not 0. So if it is 0, it is coming out of the loop. So that it is very simple to within the loop moving the value into that location. So similarly, register indirect addressing mode. The main advantage is that it makes accessing data dynamically rather than the static. So static in a sense, we directly mentioning the address, that is static address. So here the value of the static address, it may vary, it can be changed, the address can be changed, that is a static. But dynamically, whatever the value, it cannot be changed. So that is what the pointer is using as a dynamic memory. So second main advantage is looping is not possible in direct addressing mode. So looping is possible in indirect addressing mode. So let me have the program with doing the looping program. So here I want to clear the 16 RAM location. So this is my memory in the RAM. So let me have the 002 FF. I want to clear all the data here. Okay, clear in the sense I should make this to 00. All become 00. I should make the 16 in the sense 0F. Sorry, it is 0F, not FF. This 15 0F. Fine. Now what I'm going to do, first I take the accumulator, should be clearing it, CLR A, clear the accumulator. Now accumulator content become 0. Now I want to take the address where I want to be pointed by to be, it is given RAM address from the 60H. Sorry, here I taken this is 60 and this should be 60F, 6FH, 16 RAM location. So that I'll started the address pointed by 60 into the R1. So now this is your R1. This is the R1, 60 pointed into this. Now I want to put in the value into this. So I indirectly I moved the value into here. But how many times? 16 times. So I taken as R7 as a counter. So now I increment the R1, same way decrement the R7 until you are 00. I works with loop 16 times with the accumulator content move into the R1. So first it is 00, next incrementing the R1, I am making again to the R1. So like that it is all the value I made it as 00. So this is how I can make in indirectly is the same. I want to do it in the direct addressing mode. So it is highly impossible to make to the loop. So I can write the same way, like move whatever your location pointed with 60H to the accumulator content. So accumulator, the 00 like I can use next move 61H comma A. So I write this is until 6F for 16 memory location. So it is burdening, it is not good looking, it takes lot of time to executing the program, lot of instruction. Okay, so that I can minimize the length of the program to using indirect addressing mode. So might be clear with the direct and indirect addressing, and as well as the difference between the direct and indirect addressing mode. So one more concept here, we have the external direct addressing mode. So that how can I access the external memory location? So external memory, how I can access? So there are only two commands that use external direct addressing mode. So we have that move X. X, it stands for external memory location. DPTR point at your external memory data pointer. So that content is moved into the accumulator. That is a one instruction. So you want to put your data into the external memory, so that from the accumulator content you moved into the add DPTR. So these two instructions are your accessing external memory location. So one more, we have that indexed addressing mode. With the same thing, we have indexed addressing mode. So indexed, or we can call it as offset. I can add the value into your indirect addressing mode. Probably this will be used to accessing data element in lookup tables. So we can use this addressing mode to access the lookup table, right? How I can use this? One, we have the move C. This instruction used to as a lookup table with like the content of accumulator. I'm taken from the lookup table to where you pointed with the offset is A plus DPTR. From the lookup table external memory pointed to the data pointer with the offset I'm added here, so that content I move to the accumulator. That is where I'm using in the lookup table. So whenever A is 0, it is similar to this instruction. Okay. Similarly, I can take the program counter like move C with your accumulator content at your A plus PC. From the program counter also I can take that. So these two instructions are used to access the data from your lookup table. So I hope these two addressing modes are to be understand, and these two instruction also will be understand clearly. So these things will instructions will clearly works on the instruction set in the next topic. So one more point here is DPTR must first be loaded with the address of external memory. So next we'll go with the instruction set of 8051. Thank you very much.